Have the engineers separated them from the rest of the class? Why is there no table in between you? Or maybe the business students have separated you. No? You had a special area for the engineers. Okay. Oh guys, come on. Okay, so in this lesson we're going to look at how we solve equations with sine, cos or tan in it. Let's start off with some simple idea. Sine x equals a half. I want you to try and find what the x is. You'll need your calculator for this.
Always have to draw a graph.
No. Huh? 30. So, by using the second function sine on your calculator, you get x equals 30. So just to confirm that's the answer, just hit in sine 30 and you should get a half. So just check that that's the answer. Sine 30 is a half. Just type it in just to check. Yeah, you got a half as well? So we know that it works. But this is not the only answer. I want you to type in sine 300 or 150, sorry. 150. You also get a half. So it's a bit like the calculator gives you the first answer, but you need to find the second answer yourself. But you always have two answers. And what I can compare this to is if I ask you to solve x squared equals 9, on the calculator you would type in square root 9, which gives you 3. Come on. But you know that this isn't the only answer. You have a second answer. What's the second answer? Minus 3. So the second answer, you have to work it out yourself. You get the idea? So you always have two answers. The calculator gives you the first answer. How do we find the second answer? So I'll give you the rules for finding the second answer now, if you can just write this down.
Could you explain the part? Yeah.
At the end?
Yeah.
It's only an example of a similar idea. The calculator only gives you one answer for the square root, but there's actually two. Okay, can I scroll down? Yeah. Oh, right. Frozen. There we go. Okay, so the rules are sine, cos, tan. So the calculator gives you one answer. To get the second answer, it depends if you're looking at sine, cos or tan. So for sine, it's 180 degrees minus the first answer. Come in. Come on, hurry up. For cosine, it's 360 minus the first answer. And for tangent, it's 180 plus the first answer. If you were using radians, it's not any different. So if you were using radians, it would just be pi minus the first answer, 2 pi minus the first answer, and pi plus the first answer. So this is how you can make the answers. And again, just say it one more time, the answers happen in pairs here. There's two answers. The reason for two answers we'll see in the next lesson when we're looking at the graphs. But for now we'll just take this as a fact. So please write this down carefully and we'll have a look at some examples. Okay, you got that? Yes? Can I scroll down? Scrolling down? Okay, let's have a look at some simple questions first to get started. So let's start with something like sine x equals root 3 over 2. X is between 0 and 360. So that means x is sine inverse root 3 over 2, which I think is 60. When you type it in on the calculator, I'll show you now. Shift sine inverse root 3 over 2. Yeah, it's 60. And then the second answer is 180 minus the first answer, which is 120. So the two answers are 60 and 120. Okay. That's a simple one. I'll give you a quick one to try, and then we'll go on. We'll start making them more difficult. So just give me this one here. Cos x equals a half, and again, x is between 0 and 360 degrees. Okay, what's the first answer here? 60, yeah, and the second answer? 300. So the two answers are 60 and 300. Okay, continue. Continue. Right, let's have a look at something like this. You're using English, right? Please. Or I will move you. 2 sine squared minus 3 sine x plus 1 equals 0. And again, x is between 0 and 360. Okay, this isn't as simple as the last one, but I hope some people can see what type of equation this is when they look at this. It's a quadratic in sine x instead of x. Let's try and factorize it. Well, it's going to have to be a 2 sine x here and a sine x here. Has to be a 1 and a 1. But both minus. Yes. So that means we get two answers. Sine x equals a half, or sine x equals 1. The first answer here is 30. Yeah? Sine inverse a half? Yeah, it's 30. And the second answer? Yeah, 150. Yes. Sine inverse 1 is 90, yeah, and then next answer is 90 as well. So you have three answers here, 30, 90, and 150. Okay, write this one down. Okay, let's look at one that's more difficult now. Continue? Okay. Right, so before we look at more difficult ones, there's one formula to do for today, and I'll give you the proof. It's a simple formula, and I think a lot of people have probably seen it before. So this is O, A, and H. So from Pythagoras, you know A squared plus O squared equals H squared. If I divide everything by H squared, I get this. This is A over H squared plus O over H squared equals 1. But A over H is cos, and O over H is sine. So in other words, cos squared plus sine squared of x is always 1. This is actually a useful formula because it lets you change cos squared into sine squared or sine squared into cos squared, because you could say cos squared equals 1 minus sine squared, or you could say sine squared equals 1 minus cos squared. So it's useful for that reason. So please write this, and the proof I think is good to write down as well, so if you can copy this. Okay. You have that? Yep. Alright. So let's look at using this in a question. So let's say you have something like minus 3 sine x minus 2 cos squared x plus 3 equals 0. So the first thing I'll do is I'll change that cos squared. Oh, and again, x is between 0 and 360. I'll change that cos squared into sine squared. So this is minus 3 sine x minus 2 plus 2 sine squared x plus 3 equals 0. Wait for it to catch up. There you go. So this is 2 sine squared x minus 3 sine x plus 1 equals 0. This is 2 sine x minus 1 sine x minus 1 equals 0. We've seen this exact one just a moment ago. Sine x is a half and sine x equals 1. We've already worked out the answers. What were they? What was it? 30 was the first one, was it? 30, then 150, then 90. Okay, so there are the three answers then. Okay. Now on to really difficult ones. These ones are not too bad because it's just x. But we'll look at ones now where it's more than just x.
2x.
Yes, maybe even 3x. Can I scroll down? No.
Then can we use the formula you taught to like a solve for functions? Like sine number answer 1, like, and answer 2 would be like 180 minus answer 1.
You mean for like if it was 2x?
Yeah.
Yeah, there is a way. There's a process. We'll have a look at it now. Okay? Right, so let's say we have something more difficult like this. Minus 5 sine 2x plus 5 degrees minus 3 equals 0. And x must be between 0 and 360. There is a process to go through for solving this. I like to remember the steps as I, E, S and F. So I'll explain the steps as we go along. So I, E, S and F is the sort of rule. So let's explain what I mean by that. The first step, which I call the inverse step, is get this ready so you can use your calculator and use sine inverse. So you would have to rewrite this as sine 2x plus 5 degrees equals, it would be minus 3 over 5. So this is what I like to call inverse ready. So now it's ready for you to use your calculator. Okay, so write that down. This is step 1. So using your calculator here would give you sine inverse minus 3 over 5 minus 36.87 degrees. And this is the end of the inverse step. Now let's go on to the next step, E, which is what I call the extra answers step. So this is where you make all the extra answers. So we already have one answer, minus 36.87. So we know how to get the second answer here. I suppose I could call it x1 and x2 if you wanted. The second answer is 180 minus the first answer. So just be careful with the signs. Because it's minus minus, you'll end up with a number bigger than 180. So you get 216.87. Now, what's different about these problems is because of the 2 here, there's actually more answers. The rough rule is, you should have twice whatever this number is. So if this is a 2, you should have 4 answers. If it's a 3, you should have 6 answers. If it's a 1, you should have, like we did previously. Okay. So I only have 2 answers here. I need to make the extra answers. That's very easy to do. The way you make the extra answers is you take the 2 answers that you have and you add 360. And this is to make more answers. So if I add 360 to the first one here,
but we only need the answers from 0 to 360.
I am not finished yet. There is a step for that. Please let me finish. Minus 36.87 plus 360. 323.13. And next one is 216.87 plus 360, that is 576.87. Now, and that nearly ends that step. And then you realise, well, if you think about it, these aren't really for x. They're not really for x. What are they really for? It's really 2x plus 5. So rather than writing an x, x1 is really 2x plus 5. So I'll just remove these. And really this is like 2x plus 5, and this is 2x plus 5, and this is 2x plus 5. So in the previous example, we didn't have to worry about that because it was already, the angle was already x. But here the angle isn't x, the angle is a 2x plus 5. So now we're on to the next step. The S stands for simplify. We don't want 2x plus 5, we want x. So if you have, for example, 2x plus 5 equals an angle, then your x would be the angle minus 5 over 2. So we have to use this to change all the answers. So now the simplifying step, take all of these minus 5 and divide it by 2. So I might as well do the last one since it's on the calculator. 285.935. Okay, does someone have the next one? Whatever the next one might be. Minus 36.87 minus 5. No. Minus 36.87 minus 5 divided by 2. Minus 20.935. Okay, does anyone have the next ones for me?
I have the third one.
Yep.
Only 159.065.
Thank you. And then the last one?
105.93.
105.93. Like this, yeah. So now we've finished the simplify step. So that's the end of the simplify step. So the last step is the F, which I call the fixed step. So if you go back to the very start, you discover that x must be between 0 and 360. And when you look at your answers, you realize, well, this one is okay, this one is okay, this one is okay, but this one's a problem. So we need to fix this one. And we're allowed to fix by adding or subtracting 360 degrees. So we're allowed to move it left or right. In this case, what would we need to do to fix it and get it in range?
Right.
Right, so add 360. So that is 339.065. And then the next one is 105.93, 159.065, 285.935. In the exam, they usually want 3 significant figures, so the answers would be x equals 106 degrees, 159 degrees, 286 degrees, and 339 degrees. These are the 4 answers then. Yes?
In the very beginning, can't we just find the x first and then add 360?
I'll just talk about that. The reason I like to write down IESF at the start is that you'll get different answers if you go in a different order. And only this order is the one that gives you the right answers. So, like, you might think, well, can't I add 360 at the start and then do the other step later? You will get a different answer. And the reason is, if you add 360 on the start, then later when you divide by 2, the 360 that was included in the number now gets divided by 2. So it's only like you're adding 180. It's a bit complicated, but it has to be this order to get the right answer. I, E, S, F. You couldn't go out of this order. There are other ways to do this, using circles and ASTC and all this. I don't like that way. I don't like it at all, so I came up with this way. You won't see it in any book. You can call it the Stephen method if you like. I don't like the other ways to do it. I like this way because it's a step by step. You do step 1, 2, 3, 4 in this order and you have the answers. Whereas with the other thing with the circle and stuff, you have to think too much. And nobody likes thinking. Nobody likes thinking. So I would like you to do it this way. You don't have to do it this way. If you have another way to do it and you get the right answer, that's fine. But this is the recommended way to do it. It's the way I like.
I drew a graph.
Yeah.
And
See?
It's too complicated.
Exactly. And this method?
It's better.
Okay. I'm going to give you one to try to practice once you write this down. Do you have this? Yeah? Yes? What? Am I just waiting for you? Looks like I am. Scrolling down. Okay. Well, actually, what I want to open up is the calculator, so you might be okay. I want to show you that these answers work. So if you go back to the original equation, it was minus 5 sine 2x. And the first x we got was 106, so I'll put in 106. Plus 5 minus 3. What should this equal?
0.
Should equal 0. And we get a number that's nearly 0. 0.009. Let's check the second answer that it works. Yep. The third answer. Yep. And then the fourth answer. Yep. So these 4 answers solve and make the equation equal to 0. So they all work. Okay. So I'll give you one to try now. Please make sure your calculator is in radian mode for this one. Minus 7 cos minus 3x minus 5 pi over 36 plus 5 equals 0. X is between minus pi and pi. And again, make sure you're in radian mode, please. Try this one, and then I'll do it in a moment.
X is between minus 5 and 5?
Yeah.
Could you just go back to the one before and check sine?
You want to check what exactly?
Sine.
Like a plus or minus?
Yeah.
Which one?
The question.
Oh, the question.
Yes.
minus 5 sine 2x plus 5 minus 3.
So when we move the degree to the other
It's 3 over minus 5.
minus
In the questions, in the test, do they usually tell you to put the answers in the degree or the radians?
No, you have to figure that out from the equation. So here there's no degree symbol on any of the numbers, so we must be dealing in radians.
Okay.
Should we leave the answer as a fraction with pi, or should we make it a decimal?
In the exam, they usually take both. I'll probably use a decimal. Okay, there should be enough time. Has anyone finished yet? Not yet, okay.
Do we add 360 and
2 pi in this case.
2 pi?
Yeah. Okay, that should be enough time. They're not that long to do. Let's have a look at them. So the first step is inverse ready. So we get cos minus 3x minus 5 pi over 36 equals 5 over 7. So that means x is, let's switch to radian mode. Cos inverse 5 over 7, 0.7752. And that's actually really not for x, but for minus 3x minus 5 pi over 36. How do I get the second answer for cos? 2 pi minus the first answer. 5.508. How many answers should I have altogether? 6 answers. So I have these two, I need 2 more and 2 more again. So we need to add 2 pi. Has anyone done that? Yeah, what did you get?
Not for this one.
Oh, okay. Anyone have them in decimals, please? For the first one?
Yes.
No, that's too big.
7.
Oh, for the second one with the 5, maybe. 11 point...
First one, 7.058.
058.
Do we have to add or can we subtract?
No, you have to add. You must add.
Is that an example before you go to plus minus?
No, that was a different step. That was the last step.
Um,
We add 2 pi again, and what do we get? 13.34 and 18.07. Yeah. Okay, so we have our 6 answers now. But if you look at this, the simplify step, if you have minus 3x minus 5 pi over 36 equals your angle, then minus 3x equals your angle plus 5 pi over 36. So x is your angle plus 5 pi over 36 over minus 3. So we have to add 5 pi over 36, yeah, and divide by minus 3. I don't know if has anybody done that step. Yes, what answers did you get then? 0.404.
No, like 404.
Start again. Minus.
Minus 0.404. Minus 1.982.
1.982.
Minus 4.050.
Uh-huh.
and minus 2.498,
Uh-huh.
and I don't do the last two.
Okay, can someone give me the last two, please? Add 5 pi over 36 and then divide by minus 3.
Minus 4.592.
Minus 4.592. And then finally, minus 6.169. Okay. The last step is to fix. Remember I said the answer should be between minus pi and pi? That means the answer should be from minus 3.14 to 3.14. Let's see which are acceptable. Acceptable, acceptable, not acceptable, acceptable, not, and definitely not. So we need to add or subtract here. Add 2 pi. Add 2 pi. Okay, so if you can do that please and tell me what you get when I get to it. Minus 0.409. Minus 1.982.
This one, 2.208.
2.8. Yeah. Next one is minus 2.498. Next one. 1.823. And finally, if you put the answers to three significant figures, that's minus 0.409, minus 1.98, 2.21, minus 2.50, 1.82, 0.119 radians. These are the 6 answers. Okay. I know they might seem very long to do, but the good news is it's the same 4 steps every time. And in the exam, you don't usually have questions with 6 answers. It's usually questions with 4 answers. Or sometimes only 2, but usually 4 answers. Okay. You have this? Yeah. So,
but what happens if it's a tangent? Do you also have to add like a pi or
all the steps are the same except for the step that makes the second answer. It's 180 plus the first answer. But every other step is the same.
What's the difference between the last two steps?
I just rounded to 3 significant figures.
It's way better than drawing graphs or calculating.
Much better. Yeah. Question, guys? Questions?
Can I come to you later to ask about the circle?
I don't like this circle, but okay. This is the ASTC circle. Nobody likes that circle.
I do.
No, you don't. Do you? Well, there's always one unusual student in every class, so oh, no problem. Right. So your homework, which you can start now for a few minutes, it's all of question 1, and they're all short questions in number 1, and then in number 2, I, J, K. Three A and 4. So that's Okay, start them now, please.
IJK.
Yep. Can I close this?